Assalamu alaikum. We know a current carrying conductor produces magnetic field around it. In this video, we will get the expression for magnetic field due to a straight infinite long current carrying conductor. For that, I consider this one as a straight conductor named as y dash having infinite length through which current I flows in this direction. Now, I take a point O at the center of this conductor, then I connect this point O to a point P where I am going to find out the magnetic field produced due to the flow of current through this conductor. First, I connect this point O with the P this way, then P is connected to Y and Y dash this way, and do the same thing with the Y dash as well. I connect the Y dash to P. Now here, the angle between PY and OP is found to be phi 1. It is taken as phi 1. Similarly, the angle between PY dash and OP is taken as phi 2. Then, to make my work easy, I take a small portion in this infinite long straight conductor. I name that portion, small portion, as AB. The length of AB is nothing but DL, through which current I flows. As current I flows through this small line element AB, I call this one as current element. Now here point A is connected to P. Now B is also connected to P. The angle taken between APB is D5. Here the angle between APB is taken as a D5. Similarly, the angle between OPA is taken as phi. Let's know about all these things. Now, to apply trigonometry, I draw a perpendicular here, perpendicular AC, perpendicular line. Here, the angle between ABC is taken as theta. This is a perpendicular line. It makes an angle of 90 degree with the line BP. Here, perpendicular AC is drawn to line BP, which makes an angle of 90 degree, as it is obvious. Now, to find the magnetic field at point P, I am going to use the Biot-Savart law. What is that? Biot-Savart law. It says that dB vector is equal to mu naught upon 4 pi ideal sin theta upon r square. This we have studied. And to provide the direction, I use a n cap here. N cap is nothing but unit vector which points towards P. Clear? That's all about the Biot-Savart law. Here, one thing I would like to tell you. I told you this letter is known as phi. This is a letter phi. PH. Letter phi. This is how we pronounce it. Now I'll go ahead. To apply trigonometry, I have drawn this perpendicular. This I told you. Now I start with this triangle, right angle triangle. Now I start with the triangle ABC. The triangle ABC. See what I do? Sin of angle theta is taken. Sin of angle theta is taken. So what is sin of theta? Opposite side divided by hypotenuse. What is opposite side here? The opposite side is AC. No, I draw this triangle here for our convenience. One. This is theta, and here A, this B, this is C. If it is so, then this is the opposite side. This one whose length is dl is nothing but hypotenuse. Its length is dl according to the diagram. And this is the adjacent side. Okay. So opposite side is AC divided by hypotenuse is AB. The value of AB is dl that I mentioned here from the diagram. Okay. Now, if I cross multiply this, drop in here AC divided by dl and do cross multiplication to get the value of AC. Along with that, I rearrange this equation. AC is found to be equal to dl sin theta. I box this for better visibility, and I name this equation as equation number 1. Start with this. Now I will find out one more value of AC from the triangle ACP. This triangle that you see here, ACP, is nothing but a right angle triangle. So start with this triangle APC. That is the same thing. Sin of theta. Sin of d phi. If we don't have theta, here we have d phi. Angle is d phi. Sin of d phi is opposite side divided by adjacent side. Hypotenuse. I'm sorry. Hypotenuse. What is the opposite side here? Opposite side is AC, and the hypotenuse is something but this AP. AP. Here I forgot to mention that AP, the distance between A and P is taken as R. The similar way, the distance between O and P is taken as A, small a. Here, so AC upon AP is small r. From this, the value of AC is found to be equal to R sin of d phi. Got it? Now here I make a certain changes. Look at this carefully. If d phi is very small, then sin of d phi can be written as d phi. You remember this. Why do you write sin d phi equals to d phi? I'll explain this with the help of a simple example. We know sin of 0. Sin of 0 is nothing but a 0. Now, if I take d phi to be very small, I will not find a smaller value than a 0. So for sin of 0, we get the value to be equal to 0. So if you look at this carefully, now here the angle is 0 and the value obtained is also 0. This happens only when the angle is small. If it is so, if sin of 0 is equal to 0, then sin of d phi can be d phi. If it is a small angle, or if it has got a small value. I hope I have understood. Now, by keeping this in mind, the above equation AC can be written as R D phi. I take this as equation number 2. I have boxed this equation for better visibility. Now if you compare equation number 1 and 2, you'll find that both of them represents AC. Okay. So from by equating 1 and 2, from equation 1 and 2, you can write AC is equal to dl sin theta, which is again equal to RD phi. So in simple words, I can say that dl sin theta is found to be equal to RD phi. I box this for better visibility and I name this one as equation number 3. Clear? So I have 3 equations, 1, 2 and 3. I'm going to use this equation 3 here. Well, I haven't given any name to this equation. So let's give some name. I name this one as equation A. Equation A. So I substitute 3 in the equation A. So what I'll get if I do so, I get this. dV vector going to be equal to mu naught upon 4 pi. In the place of dl sin theta, I mention R d5 on R square n cap. Here, this R and this R get cancelled. This is what we obtain. Here, dV vector going to be equal to mu naught upon 4 pi I d5 upon R n cap. Now, I'll find out the value of R and I'll substitute here. To get the value of R, I take this is a triangle OPA and triangle OPA. It is given here, this triangle. Now, I draw this triangle here separately to make my work easy. The angle is 5. This P, point P is O and this one is A. Okay. The distance between OP is taken as A and the distance between AP is taken as R from the diagram. Now, see what I am going to do. I'll find out cos of angle 5. So cos of 5 is nothing but adjacent side divided by hypotenuse. What is the adjacent side here? This is the adjacent side. Adjacent side has got value A. And hypotenuse is nothing but this. And its value is R. So from this, if we cross multiply, we get the value of R equals to A upon cos 5. Here R has gone to this side and cos 5 has come down to denominator. And we get this equation. I box this for a better visibility. Now I got the value of R. This I am going to substitute here in the equation. Before doing that, I name this one as equation number 4 and this as equation number 5. Now 5 is substituted in 4. What I'll get? So dB vector mu naught upon 4 pi I d5 divided by A upon cos 5. Then here we have n cap is unit vector. Clear? Now I take this term which is present in denominator to numerator. So what I will get if I do so? I'll get this dB vector is equal to mu naught upon 4 pi. So I d5 when it's taken up, get cos 5 goes to numerator and a comes down. N cap. Alright? This is what I get. So I rearrange this one. Arrange this. Rearranged. So dB vector mu naught I upon 4 pi a cos 5 d5 n cap. Now to get the b vector from dB vector, I need to integrate this. Now this is the equation 6 is integrated or not integration. What I'll get? See, with this, if I integrate dB vector, then I will get b. As you know very well, if you integrate, integral of dx is taken as dx, and the similar integral of db is found to be equal to b. Remember this, okay? Fine. So integrate this part. Whenever we integrate something, we cannot integrate a constant. So the constant term is taken outside. If you look at the equation number 6 here, constant is nothing but mu naught I and 4 pi a. So I take it out. Cos 5 d5 and the n cap is also written here. This is how we do. Now I am going to integrate this part. If I integrate the cos 5, I will get the 4 pi a n cap. If I integrate the cos 5, we get the sin of 5. Now here I take the lower limit as minus 5 1 and upper limit as 5 2. This covers the entire angle. Okay, so I have done. Pretty so, limits are written outside the bracket in this way. Now I am going to substitute the value of 5 1 and 5 2. That is the limits in the place of 5. So what I will get if I do so? I will get this mu naught I upon 4 pi a n cap, then sin of 5 2. First, in the place of 5, I write the upper limit. 5 2 minus sin of minus 5 1. This is what I get. Here I substituted the upper limit and the lower limit. Clear? So here, sin of minus 5 1 can be written as minus sin 5. This can be written as minus sin 5. Already we have minus in here. This minus and this minus. Our multiplication becomes plus. So the next step, b is found to be equal to the b vector mu naught I upon 4 pi a n cap. What do we have? We have this sin 5 2 plus sin 5 1. This is what we get. Suppose, now as I told you earlier, here y dash is of infinite length. What is so? As we increase the length of y dash, this angle will keep increasing. Something like this. So here we have got some angle. As we increase the length of y dash, the angle will increase. What is infinite in length? Then the angle become 90 degree. This phi 1 and phi 2 angle becomes 90 degree. See? Let me show this once again. As you increase the length, this angle is going to increase. When it becomes infinity, this angle will turn into 90 degree. So phi 1 and phi 2 value will become 90. When it is when the length of the conductor is infinity. Here phi 1 is equal to phi 2 is taken as 90 degree. If it is so, in the place of phi 2 and phi 1, I put a 90 degree. If I do so, sine of 90 is nothing but 1. In the place of this, I will get 1, and in the place also, I will get 1. So 1 plus 1 becomes 2. That is in the box. Then here, B vector is going to be mu naught I upon 4 pi A n cap. So here sine of 90 plus sine of 90. Sine of 90 is 1 and sine of 90 is again 1. So 1 plus 1 is 2. I write this one here. So what I will be able to do so? See, B vector, it was mu naught upon 4 pi multiplied with I divided by A, and here we have n cap. Then within the bracket, write the sine of 90 plus the sine of 90 degree. Here I have told you why do we get 90 degree. Your phi 1 and phi 2 will become 90 degree as we keep increasing the length of y dash. Let me show this to you once again. Here, suppose this aluminum rod represents the line P y dash. If I increase the length of the conductor, slowly this angle will increase. If I keep increasing, at one point when it becomes infinity, then this line which connects P and y dash will go almost parallel to this, right? And the angle will become 90 degree. That is why for infinite length conductor, the angle phi 1 and phi 2 is taken as a 90 degree. Here I forgot to mention the vector symbol. We know sine of 90 is nothing but 1. So I am going to replace the sine of 90 with the 1. Then what I will get? Mu naught I upon 4 pi A n cap 1 plus 1 becomes 2. So this and this will cancel. It is 2. The next step, the value of B vector is found to be equal to mu naught I upon 2 pi A n cap. This is the final expression that represents a magnetic field at point P due to a straight long conductor carrying current I. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.